Okay, so today we continue on with lesson 8.5. There's two problems of the day, actually, one here, one here. I want you to pause the video and solve them. So today we begin the first of three parts that deal with add and subtract rational expressions. So far in 8.4 we looked at what? Simplifying, multiplying, and dividing. So it's only right that in 8.5 we're going to actually look at adding and subtracting. So then we'll cover all the operations. So add and subtract rational expressions. We'll start with some easy ones today. Today we're going to look at like denominators. That's the first part of the lesson. So let's take a look at this here. Number one, with like denominators, you want to add or subtract numerators, but leave denominator the same. All right, so here's what that means. Let's look at this one. A plus B, or A over C plus B over C. All right, so we add the numerators, A plus B. And it says leave denominator the same, so it's over C. And that's it. So how does this look as a real life example? Let's look at the one below. So that'd be what? 3x plus 7. So I add the numerators. And then keep the denominator the same. So you do not change the denominator at all. It's 5x squared. All right. Subtraction's the same way. So on the top we'd get what? A minus B. Keep the denominator the same, which is C. And then here we would get 9x cubed minus x squared over x plus 1. All right. Now if you notice here, we can't simplify these. Why can't I simplify the numerator here? Because I have an x to the first power and a constant. Here I have x cubed and x squared. So we're just going to leave it as is. Now, the actual problems that we do, you'll be able to simplify it a little more, combine a little more. Let's take a look at that. So here's our three steps. So example 1, perform the indicator operation. So each time, in number 1, we have to check the same denominator, or check for the same denominator. 2, if they're alike, we can add or subtract numerators. And then 3, simplify if possible. All right. So let's look at letter A. It's subtraction, right? 12 minus 2 is 10. And now, rewrite the denominator. Do not change anything in the denominator. And that's what we get. Now, step 3, though, here's what we're going to add to these problems. Simplify if possible. We simplified in lesson 5 or 8.4, right? If I look, 5 and 10, I could simplify, right? 10 divided by 5 is 2 over x. So you can actually simplify, right? 5 divided by 5 is 1. 10 divided by 5 is 2. That's how I get 2 over x. Now that's my simplest. All right, let's look at B. Common denominator again, so 3x plus 1 is just 3x plus 1 over the denominator, which is 2x plus 5. Now, can I simplify 3x plus 1? No, it's in simplest form. How about the denominator? 2x plus 5? No. Can I cancel anything out? No, they are unlike. So sometimes that'll happen, and that'll just be my answer. You have to ask yourself those questions. All right, let's look at C. I get, and I'll write here first, 2x squared plus 2 up top. Denominator, rewrite it, x squared plus 1. So that's steps 1 and 2. Step 3 says simplify if possible. So I always ask myself that. In the numerator, do they have anything in common? Well, yeah, they have a 2, right? So I'm allowed to factor out a 2 up top, like I've done before. I get x squared plus 1. All over. The denominator I can't do anything with. It's just x squared plus 1. Now, lo and behold, if you look, these are exactly the same. I mean, I don't usually write the parentheses, but let's add it to make it exactly the same. You can cancel these out. And yes, your final answer after all that work is just 2. So do you see how we're bringing back less than 8.4 with simplifying fractions into it as well? All right, now be careful with this one here. You know how we have subtraction? Do you see how there's like 2 pieces here? So I'm going to put parentheses around them. Really, we have to take this negative and distribute it to both pieces. So be very, very careful. That's the one confusing thing I think I see a lot, like a mistake that I see a lot with subtracting. So I'm actually going to rewrite it first. I'm not going to even combine them yet. So I get 4x minus 2x plus 4 up top, right? Because I distribute the negative to both. Keep it over the denominator. Combine like terms up top. 4x minus 2x is just 2x plus 4 over x minus 2. Now, can I simplify anything? Well, I know in the numerator there's a 2 in common, so let's see what happens. All right. I'm going to take a look here. They're almost the same, but there's a different sign between them. Yeah, there's not really anything I can do. So my final answer is going to be either one. I don't care. If you've factored out a common monomial and you saw it didn't work, you could leave it like that, or that would be your final answer. All right. And actually, do me a favor, go back for a second. I have no clue where this number came from. I don't know if any of you noticed this, but this is still a 2. It doesn't distribute this like a number as well. So do me a favor, go back and fix this. I just realized that. I'll make mistakes, all right? So you only distribute the negative. You don't actually change the number. Don't really know why I did that. That's the one here. So hopefully that didn't confuse you. I'll talk about it again here. All right, so when I distribute the negative, I get negative 2x plus 2. All right, 2x plus 2. And I factor out 2. They still have 2 in common. I'm left with x plus 1. Nothing cancels out. So either answer is fine. All right, so we're looking at adding and subtracting with the common denominator. Now, not all of them have a common denominator. Remember when you add subtract fractions, sometimes you had to make that happen. So we're not doing that yet per se, but we're leading up to it. The last thing is finding the least common multiple, or the LCM. So let's take a look at how that goes into our problem. Must find LCM. Factor both denominators. Step 2, find LCM by taking one of each. Choose the highest power. All right. Before I can do the LCM, what I have to do first is I'm going to draw a line here. There's 2 pieces here. I'm going to factor them into their parts, like step 1 says. So in the first one, I could take out a 5. I'm left with x squared minus 9. And yes, I can factor further because it's an x plus 3, x minus 3, right? All right. On the other one, they both have a 4 or they all have a 4 in common, not both, but all. Gives me x squared plus 6x plus 9. All right. Now I could factor this as well. All right. So on the one on the left, I get 5 times x plus 3 times x minus 3. On the right, I get 4 times x plus 3 times x plus 3. And for our purposes with these examples, if I have x plus 3 twice, all right, can't I say that's the same as a square? X plus 3 times x plus 3 is x plus 3 squared. So now I didn't find the LCM yet. I want to stop here for a second. I'm going to box my two pieces here so I can actually find the LCM. All right. Are we okay with what we did so far? Now, least common multiple means it's always bigger than what you have or the same as what you have, but it's a multiple going up. When I try to find a common denominator, I always have to make it bigger because I'm multiplying by something to get that. All right, so when I do these problems, what I like to do is underline them as I go. So let me write LCM. All right, so let's start with 5. Let's start the numbers. I have a 5 and I have a 4, right? What's the first number 5 and 4 both have in common? Now counting up. 5, 10, 15, 20, 4, 8, 12, 16, 20. They both have 20 in common. Least common multiple. All right. Could I have said 40? Yeah, I could have used 40, but we don't want a common multiple, CM. We want an LCM, or least common multiple. So 20 is the first number counting up that they both have in common. Counting up because they're multiples. Now, I have an x plus 3 here, and I have an x plus 3 here. Well, this is related to the first power, right? So if I have a first power and a second power, which one am I going to go with? Hopefully you know it's the second. Why? Because it says choose the highest power. So we're going to say x plus 3 squared. Now, we always include everything. All right, so here's my square. Now, I have one lone little piece left over. It's x minus 3. So that has to be included. The reason why I underline things is I think it makes it easier to see what's left over when I'm figuring out my LCM. So least common multiple here is 20 times x plus 3 quantity squared times x minus 3. And that will lead us into tomorrow's lesson, is where we take this part and the ion subtracting part and combine them together. Now, that's it for today. Homework's problem of the day. On assignment 9, I want you to try numbers 3 and 6.